You're watching the Wise Channel. Da-da-da-da-da. Today we're going to talk about probability. Probability. Okay, so first of all, there are three types that we talk about here. It's either going to be called theoretical, relative frequency, or subjective. For example, the probability of rolling a 7 with 2 dice is 6 out of 36. Because as I've shown you before, right, there are 6 possible ways to roll a 7 with 2 dice out of 36. That is a given. That is always true. That is never going to change. That is a number that is always the case. When it's always the case, we call that theoretical. Okay? Here's another one. This spinner, right? How many ways can you land on a number less than 8? I'm sorry, less than 4. How many ways can you land on a number less than 4? Would you agree that there's 1, 2, 3 possibilities out of 8? 3 out of 8, or 0.375. Again, this is a given. This number is never going to change. It's always going to be 3 out of 8. Okay? That is called, again, theoretical. Okay? But if we're talking about something like a census, based on census data, 5 out of 13 people living in D.C. are under the age of 16. That is for some given year. Let's say it was for 2010. Okay? Fine, 2010. That is relative frequency. Why is it relative frequency? Because it's relative to the year. That happened to be, say, 2010. 2020, that number certainly won't be the same because there's probably a different number of 16-year-olds in D.C. So we call that relative frequency. Same idea here. According to U.S. News and World Report, 4 out of 7, or 0.5714, 18-year-olds registered as Democrat this year. Well, that was for one given year. The next year is certain to be a different number. But for 1 year, that was the number. That's called relative frequency because it'll be different 1 year to the next. Okay? So theoretical, the number will never change. Relative frequency, the number changes. If I said that I believe that the Cleveland Browns will win the Super Bowl this year, well, that's called subjective. It's based on information that you may have. It may be good information, it may be bad information, but the fact is that it's subjective. Is it a fact? Obviously, it's not impossible for that to happen this year. Certainly not likely. But this is called subjective because it's something that you believe. Okay? If I said that I am certain that Miss Selipek will win the chili cook-off this year, that is subjective. It may be based on information that I have. For example, if she won the chili cook-off contest the last 4 years in a row, I could be thinking, well, she'll probably win it again. That's called subjective. Okay? All right. Now we're going to talk about dependent, independent, non-overlapping, or overlapping. What? Take a deep breath and let's take a look. All right? So, in the first situation, if you were to discover that your 2 best friends have a birthday in March, would that situation be dependent or independent? This situation is called independent. Why is this independent? Well, because one person's birthday has nothing to do with the other person's birthday. So they have nothing to do with each other. That's called independent. Hang on to that thought for a moment as I'm going to show you the difference between independent and dependent. But now we're going to talk about what's the probability of this happening. Well, how many months in the year are there? There are 12 months in a year. So what's the chances of you having a birthday in March? Well, 1 out of 12, right? So now, that's the probability of one friend having a birthday in March. What's the probability of the second friend having a birthday in March? Wouldn't that also be 1 out of 12? We multiply those two numbers together and say 1 out of 12 times 1 out of 12 equals 1 out of 144, okay? And as we want you to do for this course, we want you to divide 1 divided by 144. Could you divide 1 divided by 144 on your calculator?
0.0069.
Thank you very much. 0.0069, and that's your answer for the probability. Easy, okay? Let's talk about dependent and the difference of dependent from independent. Let's say you randomly draw 3 blue M&Ms in a row from a bag that has only 7 blue M&Ms altogether out of a total of 50 M&Ms, okay? So in other words, there's 7 blue M&Ms in a bag of 50. What are the chances of you actually picking 1 blue, 1 blue, and 1 blue? Okay, well, here's how it works. First of all, does it make sense that this situation is dependent? It depends on what you pick on each pick. Let me be more specific here, all right? The situation, first of all, is dependent, and I'm going to explain exactly why. To start with, what are the chances of you picking a blue M&M, all right, out of 50 M&Ms? How many blue M&Ms are there to start with? There's 7, right? So the chances of you picking a blue M&M is going to be 7 out of 50. But now, if you picked a blue M&M, how many blue M&Ms are left, assuming you ate that M&M? There's 6 blue M&Ms left. And how many M&Ms are left altogether after 1 was removed? 49, right? So it's 6 out of 49, okay? Meaning this situation here, this second fraction, depends on what happened on the first pick, okay? Without it, all right, without this situation, it becomes independent. But we have a situation where once you pick one, it's dependent on the previous situation. Let's say you pick the second one. Again, after you have 6 blue M&Ms, how many are left after you pick another blue M&M? 5 over 48. Very good. And now we multiply these 3 numbers. Okay? 7 times 6 times 5 is 210. And 50 times 49 times 48 is 117,600. Okay? So what is 210 divided by 117,600? 0.0018 if you round correctly. 0.0018 is the probability of picking 3 blue M&Ms back to back to back if you have 7 blue in a pack of 50 M&Ms. Okay? What's the situation here? If to draw 1 card from a standard deck of cards and get either a queen or an ace. How many queens are there? 4. How many aces are there? 4. So that would simply be 8 out of 52, right? Okay. So the situation here is non-overlapping. What? This is non-overlapping. it will be easier to explain this when I get to an overlapping situation. So let me just say for now that it's non-overlapping because the two, getting the queen or an ace doesn't overlap. I'm going to show you what I mean by that in just a moment. All right? So the probability here is going to be 8 out of 52. On your calculator, if you do 8 divided by 52, you will get 0.1538. 0.1538. Again, because we want 4 decimal places, okay? Let's see what an overlapping situation is to compare it to what non-overlapping is. All right. What's the probability of drawing one card from a standard deck of cards and getting either a 3 or a black card? This is overlapping. Why? This is an overlapping situation because to get a 3 or a black card, how many 3s are there?
4.
There's 4 3s. How many black cards are there? There's 26 black cards, but wait a minute. 2 of those black cards are 3s, right? We can't count those 3s twice. That's overlapping. Okay? So we have to make sure we don't count the 3s twice. So here's what we do. We say that the probability of getting a 3 would be 4 out of 52. What's the probability of getting a black card? 26 out of 52. Okay, now 4 plus 26 would be 30 out of 52, but we don't want to count the 3s twice. Okay, so how many black 3s are there? There's 2 black 3s. So in order to not count the black 3s twice, I have to subtract 2 out of 52. Because if I don't subtract 2, I will be counting them twice. So 4 plus 26 is 30, minus 2 gives me 28 out of 52. And if I do 28 divided by 52 on my calculator, I will get 0.5385. And that's the probability of getting a 3 or a black card. You've been watching the Weiss channel. Da 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 da.